go ahead and make the shell mesh in here. So we'll ungroup these curves, and just like we did before, deselect those ones that aren't starting at the deck and use the divide by length, and we'll use 1 meter again. And you can see these points at the top are very close to the bottom of the other deck, but not quite on. If we zoom in very tight, you can see there's a small gap there. So this is where I would use the points from the adjacent mesh. So in this view, we can come in and just grab that whole top row and delete it. And what I would do is come in and take the upper hull mesh that we have, and we would do the extract points. Then I deselect the bottom row from that, and then hit delete to get rid of the rest of those points. And while I'm thinking of it, there was that extra curve in the bow that I'm going to delete. And this works out rather well because now I don't have to mark the ends of those curves anymore. I just use the points from the adjacent mesh. I could have selected all those curves again and said mark the curve end after deleting that point that was near it. But it's probably easier to just use the points from the other mesh because you know exactly where you need them. But we have a bunch of extras at the end here, but it's easy enough to come in and select those. And you can, if you're worried that you may have selected something else, whenever you drag around a group of objects or whatever, it tells you everything that was selected by that drag. So I only got 39 points added. And this is something to be careful of because if you happen to have the mesh nodes turned on, the control points for the mesh turned on, and you're selecting something, I'm only trying to select these points, but as you'll notice, I selected 39 mesh points as well as the 39 points. And if I delete them, that lower row on the mesh would disappear too, because once you get rid of one control point, any mesh element that relies on it gets deleted as well. So you'd want to hit escape before doing those selections. It's just something to be careful of. If you were working on the mesh to manipulate nodes, you can accidentally select them when you're grabbing with a window. So we'll delete those extra points. And up at the bow here, these are relatively straight. So we'll just grab these remaining curves and we'll use the section command and just sort of create a continuation of each one of these stiffener traces. This is the deck here, so we can add a point at the end of the bow curve, the stem curve. The other thing we want to note here is that we're going to have frames every 2 meters. So we'll have a frame at 0, at 2, 4, 6, and so forth. So this one is going to be a frame. So let's put a point on center line underneath there so our frame doesn't have to kick forward or anything. And this one is potentially going to be a frame, but because we have a deck there, maybe we'll just terminate that frame at the deck and not worry about putting a point here. Or we can continue the frame down, but we'll move this point. Actually, I don't want to move that point up because then the stiffener trace, if it goes to the stem, or if we had a breast hook in there or something, we would want a node in line there. So we'll go ahead and leave that for now and probably just terminate that frame above the second deck. But again, you would be going by your structural drawing, so it's whatever they indicate, that's what we'd be modeling. We can grab all of these points, create the mesh, and convert to quads. Up in the bow, we've got a few that still need to be merged in here. And when we do this, you may want to look in multiple views. Now these seem to be ones that we'd want to convert to quads, but like in this area, this one looks like, at least from the profile view, I might prefer to have the triangle up at the top and this be the quad. But when I look at it in 3D from this side, if I had the triangle going up there, maybe I actually do prefer having one of these others to be the quad. So from this view, maybe I do want to have that as my quad in that region. So you do want to be a little bit careful when you're working in these views where the surface is going into the screen. And sometimes it's convenient to swing over to this perspective view to see how you actually want to merge your meshes. And this one can probably be, can do those as well, just to minimize the number of tries in there. And where's that point? So this is, that is a curve that we're looking at there, which is why it looks normal in this view, but we seem to have a large quad there. Now to split that quad, the easiest way to do that now, since that already got merged in, is probably to extract it and then use this triangulate mesh and grab the rest of the mesh and just type join to join it back in. And that's a nice easy way of doing that. Since it was on the edge, it wasn't really easy for me to delete that quad and then use the add mesh face, because if I would have gone from this edge to that edge, it would have joined the meshes above and below the second deck just at that location. And I couldn't go this way because we didn't have an adjacent mesh edge on center line. So sometimes it's very easy to just extract and then split it and join it back in when you need to get that triangle back in. And then we can merge this one. Now this is another thing that we need to be careful of, is that when you have a concave surface, sometimes you get these extra meshes in here. And one thing I think I didn't mention the other day was that, you know, when you go to extract connected mesh faces, you can set a tolerance angle for how it searches out, but you can also modify the selection. So I had a seed, kind of like in Maestro, when you select an element, you can say add by seed. Similarly, when you're extracting connected mesh faces, you can modify the selection and add another sort of seed face in there. And then I extract these and delete them. Now our normals might be a little odd. Check the directions. They actually don't look bad, but when you delete something, yeah, you can see these, where those odd right angle was in the mesh, it sort of distorted our normals at the corner there. But now that we've deleted that flat edge to the mesh, we can rebuild mesh normals, and you can see the shading updated. And now if we were to check direction, everything is good. Now on the shell, that's important because we want to make sure our normals are in an appropriate direction, mainly because we'll typically use the mesh normal when we're exporting the beams. When it goes to export the beam traces on the hull, I like to use, you know, normal to mesh as the direction, rather than setting a direction of either straight down or inboard or forward, like you could on a deck or a bulkhead. I like to keep them normal to the mesh, but in order to do that, we want to make sure we have the right normal direction. We can select these points and delete them now. And then as we work aft, at some point we need to create a division of where we want our side shell stringers and our bottom shell stringers. So this was a useful command that I used this morning that you might like. You can create a curve on surface. So under the standard toolbar over here in the curve creation toolbar, you can cascade that down, and one of the items is interpolate a curve on the surface. So if I select the shell surface there, and I can say, well, this corner is sort of a breaking point between my side shell stiffeners and my bottom shell stiffeners, so I'll set that point there. And if I run it up to the corner of the transom here, right along the radius, I can put a point there. And that's about where I want my division to be. So we turn off the surfaces, and I'll use that curve as a reference point for where I want to transition from my side shell to my bottom shell. And we would make the next set of stiffeners here. Let me regroup those curves. To make them a little easier to select, we'll get rid of the mesh, and we'll just group those so that when we're selecting these, we don't get them by mistake. And I will unselect those ones at the bow, divide by length, and we'll use the 1 meter again. And we'll do exactly what we did before. We have one point that's near the top, so I'm going to delete that top row of nodes. We will use extracted nodes from the mesh above. So we'll unselect the bottom row and then delete the rest. It has the same end location, so we don't have to worry about deleting any extras there. For this bow portion, stiffeners are running fairly flat. We'll do the exact same thing we did the last time up above, and we'll use the section command and extend these forward. And we need to drop a point at the bottom there. Select all of these points and make our mesh. And again, we have that issue with the concave set of points at the bottom, creating that extra mesh. So we'll extract that. It happened again over here, so we can edit the selection and include those. And I think that's the only spot. So we'll extract them and delete them. Now you can see traces along the horizontally where we want all our stiffener traces, so we can go ahead and quadrangulate the mesh. It's keeping all the ones that we want. We can manually merge a few of these extras. And we'll clean up those points, just select them and delete them. So now we've got a good portion of the hull done here. I will group these curves again and exclude the mesh. And this was the area that was interesting. I shouldn't have merged these in. These curves here, there is a deck back here. I should have left those out. So let me ungroup these. And they were previously split and joined back together. So if we explode them, you can see the split location remains. So I can just unselect the ones on top there. And I can join these bottom ones back together, and the 47 curves turn into 20. And we can group them so we don't lose them. These are individual curves, but we can group them also. Let me check the direction. I'll point up so we can use the 1 meter length of curves. Again, they're not quite touching the mesh there, so we'll do that same trick to delete the top row. And here we're going to extract both this and forward, so we get these points and those points. And we'll just do, we still have extract points available. Select these. This is another little trick. If you have difficulty selecting, you can zoom in, and I'm holding the control key down and I'm holding the left mouse key to start my selection, but I can zoom in and out with the wheel. So I can zoom out and then zoom back in at the other end if I need a little more control over where to start and stop the selection. Because when you're zoomed out, sometimes it can be very difficult to, if you go to pick a spot, it's going to grab the wrong object. If I'm trying to drag a window rather than select an object, I need to zoom in close enough that I have some blank space that it won't automatically select the nearest point or curve or mesh. Delete that, and there's 2 points there, so I'm going to delete one of the duplicates because that one was from 2 different meshes. And select the points, create our mesh. To quads, delete the points, and we can join so they get selected together. Those curves. Okay, so this is the part that I wanted to show you. when I was looking at this, I was deciding, okay, what's a good way of continuing these curves aft? I can't use, the 1 meter up from the bottom anymore, and it's not necessarily a uniform spacing from the top. It was slightly greater than a meter there. I could measure this distance and take all of these curves and change the direction and tell it to divide them on that increment, and just keep the first row, and then grab all the curves again and use the distance to the second point and tell it to divide on that increment and generate the second stiffener and keep working my way down. But that's a bit of a pain. A much easier way of doing this is to turn on the surfaces. And what we'll do is we'll use the section command. And right at the deck here, I'm going to create a stiffener, or a trace rather, on the hull from that point aft. We'll select the surface, we'll say section, we start at that location and go aft. And okay, so there's our curve trace along the hull. And there is a command called curve offset. And you can offset a curve in a given direction, but you can also offset the curve on a reference surface. And that's what we're going to do here. So we'll get a parallel curve to that deck, but on the hull surface. So we'll select a base surface, and it gives you a direction, and you can just type in a distance. So if I knew the distance down to this first point, I could just type it in. But they also give an option for through point. So I can use that through point option and then simply click on this node, and I'll get a continuous trace, from that node along the surface that is a constant offset from our deck curve. And then I can do the next one down, the next one down, and so forth, and generate that series of curves. Now that series of curves wraps around the radius, which is going to be our braking location. But since the transverse curves and these new curves are all on the surface, they're going to intersect in 3D space. So we will grab all of these curves, and we can just say intersect. And now we have all the points that we want for our mesh back there. Now it goes too far, so we're going to delete some of these points, any of the ones that are below that transition curve we created. And you can see we also accidentally created a few curves up forward, because that curve that we were using for our seed only started at this location and ran aft. So when it extended the curve forward to the opposite end of the surface, it began to wander, and they crisscrossed up forward, made some extra points. So we'll unselect these and delete those extra ones up there. And we will delete the points that are below the curve, since we don't want those included in our mesh here. We can leave those in there. Those will be part of the side. Now, when we create similar curves on the bottom, we don't necessarily have to come up and meet. We could use the fill hole command for the mesh to fill in, any small gaps in here, or we can create all of our points and then generate the mesh later. Done with these longitudinal curves, so we can get rid of them. We have our points. We need the additional points from the adjacent meshes. Simply extract them. These. And then we can create the mesh from there. Get rid of that curve so we don't use that as part of our mesh. Now, we know, we have a stepped mesh here, but when it goes to create the mesh, it's going to close those in. So we'd have to manually go in and get rid of these extra pieces at the steps. And in the remainder, convert to quads. And we would do the same thing in this region. Now for the bottom, we can grab all of those. Well, let's do this one real quick first. And we'll do the exact same thing as we did before. We grab our surface, we cut a section, and we'll cut it along the deck there. And we use our offset curve on surface. Select the hull, and we use through point, and we can just click on these. And we don't need that one, it's below the curve already. And again, we don't have to do two sets because we only want we want all the intersections between these. It grabbed a geometry point when I went to create the window, so it moved all my points. So I'll hit Control Z to undo that. Now it still kept the selection set, so I'll start it way out here so I can unselect all of those. Hit delete. Grab this mesh. Extract points. Those, and again, we'll delete all of those points that are low. Our area of interest. So and again, we have to clean up these steps. I should have left that bottom point out, and we wouldn't have had all of those tries created. But we have a couple steps there. That. This was a mistake. I forgot to delete any of those points that were created up forward. So these points, when I selected all my points, got included when the mesh was created. I should have unselected all of those. Did these points. This time I will remember to unselect that. Do creating the mesh. So if we select points, select the bottom one, select those, and select the forward ones. And that looks a little better. But that offset on surface is a very handy command. I have used that when I was creating stiffener traces on a hull from an expansion drawing. Now, if you have a 3D model and you already have your stiffener traces in 3D space, it makes it much easier to generate these traces in your 3D model. If you don't, and you just have the paper expansion drawing, unless you know exactly how that expansion drawing was created, it can be a little difficult to map back onto a 3D model, especially up in the bow region where if you have any tumble home or if you have a fairly rounded bow, if it's very sharp, it'll expand a little better in the drawing. But if it's, you can get a lot of distortion in the expansion drawing if you have a bow that's very flat. We have most of the hull done there. For the bottom, we would use the curve divide by length. We'll use the same standard 1 meter, and we get a pretty good layout of what our bottom stiffeners are going to be there. And we would do the same thing for these two groups. Obviously, we have an overlap here, so we'd get rid of a lot of these nodes. you get an idea for how we would finish this up. You get a good idea of how exactly these meshes would be made, because now all we have to do is select these points, extract the bottom points on the existing shell mesh to make sure we get a good connection there, and we can create that bottom mesh.